How your car's climate control actually works. Press a button. Feel the cold air simply, right? Not even close. Behind that chill breeze is one of the most complex systems in your car. And today, we're cracking it open. From hidden sensors to tiny moving parts, your car's climate control is a high-tech dance designed to keep you perfectly comfortable year-round. It's more than cool. It's seriously impressive. Let's dive in and see what's really happening behind your dashboard. Chapter 1. The basics, more than just hot or cold. The principal idea behind the climate control system of your car is comfort. It is either a hot summer afternoon or a cold winter morning, and it should be the aim of the cabin to maintain it at the optimum temperature. However, as opposed to their older counterparts, where you would simply turn the fan or temperature dial, the new systems are intelligent. Climate control involves a combination of mechanical power, electrical power, and digital power. The HVAC system, aka the heating, ventilation, and air conditioning system, takes care of the air quality and the air comfort in the cabin. The system either draws air outside or recirculates the cabin air, passing it through a mixture of filters, vents, and temperature-modifying elements. The contemporary systems incorporate the use of computers and electronic control units, which read real-time information on the sensors, which gauges the air in the cabin temperature, external temperature, and even humidity of air. These sensors allow the system to change the fan's speed, the airflow direction, and the heating or cooling to employ. Your ability to program a temperature and trust the system to maintain it using this high degree of automation in itself is unbelievable. Chapter 2. The heating system. Borrowing engine heat. Well, we will begin on the warm side of things. Your automobile does not have a heater such as a furnace in your house. It intelligently instead recycles engine-generated heat. As your engine operates, it emits a considerable amount of heat, and in an attempt to avoid overheating, coolant is circulated around the engine, after which it goes to the radiator. What it does is to utilize this heating system to warm you up during colder seasons. The gadget that performs the job is termed a heater core. It is a mini radiator piece pulled out behind your dashboard. The HVAC fan blows air passing over the heater core as hot coolant passes through the heater core. This hot air is then passed on to your cabin via the vents. The amount of warm or cool air being blended together to the required temperature is governed by the use of blend doors. That said, the process will require engine heat, so you might find your heater to not operate instantly upon startup. Your engine needs time to heat up. The more costly vehicles now equip supplemental electric heaters to assist during the initial few moments of motor vehicles' travel, yet in low temperatures. Chapter 3. Air conditioning. Chilling with refrigerant. Your car offers you cold air by using the closed-loop refrigeration system when required. It begins with the AC compressor, a mechanical pump driven by the engine serpentine belt, or in an electric car, electricity. The compressor accepts the low-pressure refrigerant gas and produces the increased pressure and temperature of the gas in a state of a vapor. This is the commencement of the cooling. The vapor then moves to the condenser, which is located before the radiator. As the refrigerant passes through the condenser, it cools to the external air so that it condenses into high-pressure liquid. Then, this liquid is passed through an expansion valve or an orifice tube, where it is rapidly reduced in pressure and heat. The refrigerant will now be in the low pressure and cold condition, which will enter the evaporator coil in the HVAC box. Chapter 4. Dual Zone and Tri-Zone. Climate systems, have you wondered how it is that the driver and the passenger can turn the temperature settings to be entirely different? This happens due to multi-zone climate control. These systems enable different cabins, the driver's side, the passenger side, as well as the rear seat, to work independently. Such an attribute is becoming more prevalent with mid-range and luxury cars, and this is accomplished through the application of more sensors and actuators. Every single zone is related to a temperature sensor plus blend door actuator. These components make the airflow and temperature per section adjustable. One can take an example whereby both the driver and the passenger may have different temperatures. The former may be satisfied with a chilly 68 degrees F, whereas the latter may prefer a warmer 75 degrees F. Warm and cool air are mixed in a proper way, and then it is sent by the right vents. Chapter 5. Sensors and Smarts. The brain behind the breeze. Without a slew of intelligent sensors keeping things out of view, modern climate control would not happen. Temperature sensors within the interior of the cabin determine the current state within the cabin and adjust the internal system in real time to meet your desired temperature. External temperature sensors monitor the temperature outside the automobile and assist it to decide the moment to toggle the heating unit on and off, and vice versa. There are other sensors, such as solar sensors, that measure intensity of sunlight. Where direct sunlight is exposed to one side of the car, the system balances by providing more of the cooling there. Humidity sensors reduce window fogging by regulating airflow and are even available in more advanced vehicles and sense air quality, especially pollutants, so as to enable air purification options. This data is then relayed over to a central control unit, or what might be regarded as the brain of the system, where it is processed and acted upon via actuators and blend doors. It will guarantee maximum comfort without the continued intervention of the driver. There are systems which even use the GPS and navigation to predict sunlight on various areas of the car based upon which way you are facing. Chapter 6. Cabin Air Filters. Breathing easy. Inside, clean air is not a luxury, more so when one lives in the city or has allergies. Your cabin air filter keeps the inside air of the car free of dust, pollen, mold, and even poisonous gases. This filter is normally found behind the glove box or under the dashboard, and its aim is to filter contaminants before entering air into the HVAC system. With time, the filter becomes full of debris, limiting the flow of air and stressing the climate system. This may create reduced fan performance, bad smells, and motor burnout on blowers. Activated carbon is also present in many current filters and can counteract smells and capture gases such as ozone or exhaust. The cabin air filter should be changed at every 12,000 to 15,000 miles, according to the majority of car manufacturers. It is a very straightforward maintenance procedure that enhances system efficiency and quality of air. A musty smell or foggy windows may indicate that you have a problem with your cabin filter and need to replace it. This will make the ride healthier and more comfortable to all the passengers, being clean. Chapter 7. Recirculation mode versus fresh air mode. The air in your car switches between intake of recirculated air and inhaling fresh air. Both serve different purposes. Recirculation mode. This mode is used to recycle air that is in the cabin. This mode cools the air at a quicker rate and effectively suits hot days when it is undesirable to have the cool air working in hot outside air come into the building, thus making the cooling less efficient. It also blocks external odors, smoke, or external pollution. Fresh air mode, on its part, draws in the outside air and increases the freshness inside the cabin and prevents the accumulation of moisture. This mode plays an important role in avoiding the stuffiness of the interior, particularly during long drives. Nevertheless, it may introduce allergens or pollution or even exhaust fumes in the event that you live in bad traffic. Chapter 8. Automatic Climate Control. Set it and forget it. Automatic climate control leaves no guessing around in regard to being comfortable in the cabin during driving. Rather than having to continuously fiddle with the knobs and buttons to regulate the temperature, speed of the fan, or the servo to direct the air somewhere, you just select your preferred temperature, say 22 degrees Celsius, and leave it at that. Since that moment, it constantly keeps an eye on the cabin and the outside environment in order to make real-time adjustments to keep you comfortable, regardless of what is going on outside. All this convenience can be achieved courtesy of a system of clever sensors and actuators that work in the background. These sensors are able to read the temperature in the cabin, the external air temperature, strength of sunlight, and even the degree of humid air. This information is processed by the control unit of the system, and it would make intelligent decisions, such as, in case it is a hot summer afternoon, it may first blow cool air at its full volume, and the air inside will soon cool down to a comfortable level. Then, when the interior gets cooler, it automatically slows down the fan speed so that it keeps the level steady and comfortable, not too noisy and too cold. Chapter 9. Climate Control in Electric Vehicles. Electric cars, EVs, do not control climate in the same way due to the absence of an engine that dissipates waste heat. Heating should be produced either by means of the electric resistance heater or some sophisticated heat pump system. These systems are effective, however, they actually draw power directly off the vehicle battery, and this may impinge on driving range. The manufacturers, such as Tesla and Hyundai, have advanced this by creating climates that utilize heat pumps. Chapter 10. Maintenance. Tips to keep it running smooth. Regular checkup of your climate control system would help in creating efficiency and performance and avoiding the overall incurred repair expenses. The easiest thing you can do is to change the cabin air filter on a regular basis. Airflow is obstructed by a clogged filter, and the system needs more work, causing it to have a shorter life. Starting the AC every now and then, even during winter, can keep seals lubricated and keep mold out of the evaporator. Most newer cars will also have things like infotainment that can give you diagnostic warnings when something may be wrong. Your car may not have these, so you can test cooling efficiency using simple tools such as vent thermometers. Maintenance of your climate control system not only ensures that you have a comfortable time, it also maintains the value of a vehicle. So the next time you adjust the temperature in your car, remember, it's not just a button press. It's a symphony of sensors, compressors, motors, and microchips, all working together to create your perfect climate. From reusing engine heat to harnessing the cold power of refrigerants, your climate control system is an engineering marvel that makes every journey just a little more comfortable. Tap the screen for more deep dives into the tech inside your car, because what you can't see is just as cool.